All right, it
All right.
should be starting.
Yep, I see it. Steven, it is balls in your court.
Yeah, so I was reading the comments that John left on my PR, and I had a talk with Keith yesterday. For some context, this is about the multi-cluster stuff, and specifically how WDS works. My understanding is that in each cluster, we would have, and for each kind of cluster network, and it's this comment specifically, a pair, we would have workload. So in each cluster, you'd have a workload that represents all the remote workloads for a service in a remote cluster. Does that make sense? Like the main point here is that each cluster is going to have a different view of the existing workloads in a multi-cluster context.
May.
But the comment John wrote makes it seem like the WS protocol is not contextual. So then the view of what workloads exist and which don't would be uniform across all clusters.
Well, is John here? I cannot speak for him, but I can tell you that always we had from the beginning of multi-network and everything, we had two modes. We had the flat network mode, where indeed it's perfectly fine to, I mean, it's reasonable to have a flat view. I mean, have every cluster get all the endpoints for across the entire mesh. Because again, the IPs make sense.
Yeah.
However, if we are in a non-flat network where you may have duplicate IP addresses and other things, it's completely useless to get the each individual IP when you cannot reach the IP and the IP is duplicated with 5 others. Even if you get the network as well, it still doesn't help you in any way because you cannot do anything with that IP address. And for a very large network, even if you have a flat network, it is useful to collapse, basically, to say that since we need to go through a waypoint to apply policy in the remote cluster anyway, instead of sending 20 endpoints that are completely useless because you'll never reach them, you send the IP address of the whatever it is, waypoint, east-west gateway, it doesn't matter how you call it. But it's the IP address that allows you to reach, to tunnel through and to apply policies, and the weight of 20.
Yeah.
And then in each cluster, you have a different view because in cluster 1, you will see the waypoint for cluster B with weight 20 and whatever endpoint you have locally. In cluster B, you'll see the local endpoints that are existing in cluster B with the 20, plus the 3 or 4 in cluster A, represented as a waypoint for B2A.
Right.
Does
So
that
for
make sense?
multi-network, it has to be contextual.
Yeah.
For multi-network is mandatory. There is no way. I mean, you could send it. It's just waste of resources and confusion and doesn't help anyone. It's just traffic and churn on the server because you are not going to do anything with it.
Yeah. I agree. So I guess from a more implementation point of view, would it be fair to say, hey, if this workload has a network gateway, we should use the network gateway?
Yes.
That is what you want again. So the point is there are many different approaches to, I mean, goals for the users. Some users want raw performance and for L4, they don't want to go through waypoints. They don't care about enforcing policy at cluster boundaries. They just want quickest way to go from A to B and for example, if you don't have a waypoint at all, you don't have a east-west gateway, you just have multiple clusters doing security only with zTunnel and IP and L4 policies. In this case, what Johnny described is the best option because then you have, send all the endpoints, you have flat network so you can reach them, you don't have east-west gateways. It's not really the use case that Kit is describing. Anyway, that's my understanding and my memory of what we designed the first time. It can change.
What did Mike say? I thought John said something somewhere about the presence of a network, not necessarily in the queue. Yeah, and maybe this is just about how general I want my implementation to be, of like it works just for this network to the multi-cluster work case versus do we want it to be a little more general and like look at the actual networks and say, oh, if it's in a different network, use the network gateway.
Yeah, one thing you could do. So to clarify, I think Stephen, maybe you can answer this. This is all happening after endpoint selection, correct?
Yes. So you give it say a service VIP, and then the existing code will resolve to a workload, and then I'm starting off at the point where I have a workload that I want to connect to, which might be my useless gateway.
Okay, gotcha. Okay, so the crap, I just blanked out. The president. Oh yeah. So one other thing that you could do is, if you want it to be consistent, is you could do. I think you and I talked about this a little bit, Stephen. About you could do a lookup of the network gateway IP to find the service and for that network gateway, even if it's an IP, not just namespace host name, and that might make the implementations. Excuse me.
Sorry, look up the service or a workload.
Look up the workloads for the. Look, I think it's probably a two-step process where you look up the service and the workloads, or you've got an index potentially. Yeah. But yeah, you look up the workload for the east-west gateway and then send to that. So that might make things a bit more consistent, because that will look similar to what you do in a flat network scenario. You could do the same thing for the multi-network scenario too, if you want the same implementation each time.
Okay, but okay, that helps. So the point is, WDS is kind of contextual in this scenario.
Maybe one thought is, maybe we should find a name for the two modes, because it's confusing both us and our users. I don't know what is the proper name, but we should probably distinguish between the situation where you have flat trust, basically. So you have equal trust in all workloads and middle boxes and configuration, everything across the entire mesh. And the case where you do want to make some boundary check between clusters. And the second case is also identical with the non-flat network, because in both non-flat network and you want to enforce policies, you must bounce through the gateway. While in the first case, where it's flat network, flat trust, flat everything, you don't have to.
Okay. Wait, can you say that again?
So first case, you trust equally everything. So if you have a cluster in say in Russia, and you have a cluster in US, you say no problem. So my cluster, I trust them equally. Nothing wrong can happen. So they are both equally trusted. If you also have a flat network, then you are in the case where you can have WDS returning a consistent view, and you don't have to go through waypoints. If you are not in this case, you either don't trust the cluster in Russia, or you don't trust you don't have a flat network, then it's mandatory to go through some waypoint that enforces policies between cluster and deals with the non-flat.
Okay, so this is like more general, like there are like two modes that we can talk about.
Yeah, we need to distinguish in documentation and in the code. I need to make sure that we have the two situations. I mean, flat versus non-flat.
Okay.
So we actually not documented, it's the wrong word, but we explored some of this in the control plane doc a couple of days ago. We've made some changes there. I think, Costin, what you're saying is it's like the single network versus multi-network distinction that exists today, but we have to add the waypoint trust model into that. Is that what you're saying?
Yes, I mean, it doesn't have to be. That's something that maybe it's controversial. It doesn't have to be waypoint. I mean, it's waypoint is just a gateway. So there is some gateways that can deal with the policy enforcement.
Yes, some L7
gateway. Yeah, some L7. Some L7. Yeah.
Ian, go ahead.
Yeah. So I think the contentious point here is Istio gonna serve a bespoke view of WDS to each individual cluster? And I think the answer should be no, probably. They all get the same WDS config. Yeah? Or no?
No,
That's not
it's
possible
quite
on
different.
multi-network. That's not
That-
possible on
That's what we
multi-network.
said, yes. Yes. And I don't think it's controversial. I mean, it was never the case. Whenever we had multi-network, we had a bespoke, I mean, each cluster got a different view of WDS.
It's the same shape of WDS. You have your local workloads, and then you'll have some how should you say,
Some
like
remote
facade.
IPs.
Yeah, then you have workload support that represent remote endpoints, but the actual details of the WDS is going to look different. Does that make sense, Ian?
I'm just trying to understand like the context of John's comment. It seems like what we want is a local endpoint might have an east-west gateway, and we can still say that it does. But if you're on the same network, you don't need to use it.
Yes.
And we should figure that out in ztunnel, not in Istio D, and serve a different view depending on that.
I believe Istio D is returning. It's aware. I mean, the network parameter that is passed when we connect to Istio D, that determines the client network. So we know Istio D knows in which network you are, and based on the network, it's just selecting all the endpoints for that particular network. If network is equal, then it's returning the endpoints, and if network is different, then it's returning the combination of the east-west gateway.
And if it's returning the east-west gateway, it's not going to have any, well, it wouldn't make any sense to put any local IPs in the workload, right?
It
Or
makes
any
little sense to
IPs
do.
besides the gateway. Yeah.
Yeah. So there wouldn't be a case where it would have both a local IP and an east-west gateway IP.
No, it will have a set of local IPs, also endpoints in the same cluster, or flat network if you want, same network. Sorry, not same cluster, same network, plus gateways to all the other networks. So endpoints in different networks will be represented through the gateway IP, not the individual IPs, because they would overlap with the local network.
But I'm saying like in a single WDS.
The WS will combine. I mean, when you get from Istio D, you get a response, you get a collection of IPs.
Oh, sorry.
Some of the IPs are local. Sorry?
In a single workload.
Yeah, as a client workload, well, in a node. I mean, you are in a VM running ztunnel. Connect to Istio D. For a particular destination, you get a list of 5 IP addresses. 4 of them are workloads in the same network. And one of them is an IP of a gateway with a weight based on how many workloads are on the remote cluster, remote network.
Okay, I think maybe the confusion here is that in the way we were doing the WDS is that there's one field for network gateway and then another field for IPs. So in a single workload, it's possible to have, say, a local IP and a network gateway IP.
I don't think Istio should ever send that.
Okay. Because that was kind of my understanding of Ian's point, where Ian was saying that could be possible and we should account for that.
Well, there are some use cases we discussed in the past. So what Louis was calling via, I mean, is basically if you have a use case for that. I mean, if you actually want to know the IPs that exist on the other endpoint, even if you don't do anything with them, maybe they have you send some labels, maybe for other purposes, then you could, instead of sending one IP as a gateway with a weight 5 or 20, you send 20 IPs, each of them having a pair of IPs, a gateway IP and the actual destination IP.
I thought Steven was asking about the case where you've got a local endpoint in your local cluster, and that local endpoint for that local workload has a network gateway field set.
No, I was kind of talking about both.
Yeah, there's so many cases,
Right.
but I wouldn't say there are no use case. What I learned in Istio is that for absolutely everything there is someone who has a use case. But we have, I mean, there is a choice. I mean, the choice is between sending the collapsed, I mean, for 20, it's easy, but if you have 1,000 and what, 10,000 endpoints that flip-flop, go up and down and so forth in the remote cluster, and you have 100 clusters, it's not very efficient to send this kind of traffic every time an endpoint changes to inform everyone, when it's completely useless and there was another discussion, I don't know if people remember, for the auto scaling, because that's also an important factor. If you may have a cluster that has 3 endpoints, but you have capacity to auto scale to 100. In this case, you can send a weight of 100, indicating that that cluster can handle 100. And it will be misleading to have the weight 3, because again, you want to split traffic, take into account that you have capacity for more, because it auto scales. I don't know if I confused it for you completely, but
okay, I think that's helpful. So I guess the answer, my question, so I have something to work off of, is if there's a network gateway, should I use it?
Yeah.
Okay.
When you need to cross a network bound. If you don't need to cross a network bound, why would you need to use it?
Well, oh, sorry, go ahead.
The trust issue. I mean, again, cluster in Russia, cluster in US, you want to enforce policy when at the border.
But you built them on a flat network, even though they can't trust each other?
That's true. Well, again, with IPv6, flat network is kind of, I mean, you no longer need, there's, I wouldn't call it flat, but I mean, if you have firewalls and policy enforcement, maybe we can call it non-flat, because you have a good point. I mean, even if you are on IPv6 and everyone has routable addresses, doesn't mean that it's flat, because you may have firewalls.
But you can also enforce policy on your waypoint. Doesn't have to be through your network gateway, right?
You need to enforce the policy in the destination. I mean, it is a policy for when traffic coming to US, need to enforce policy in US. You cannot trust the waypoint in Russia.
Maybe some pseudocode will help here. I think what I'm hearing Ian say, if local network of the Z tunnel is not equal to chosen endpoint network, then go to network gateway. Is that the gist of it, Ian? You need both parts of that if statement?
Yeah, I think that's, I mean, to be fair, I think that's what John is at least getting at in his comment that led to this. And that way you can cover multiple scenarios, and without having all of the special logic about what WDS to serve in Istio D.
Yeah,
Okay.
that makes sense to me too. It's really about reducing that hop if we don't need to go through the network gateway.
Okay, so the point is more like we're not relying on a specific behavior of SOD and how it presents the WDS and the workloads and whatnot. But in the most common case, it'll usually be that if there's a network gateway, it will also be in a separate network. Right now, it's just how we implement the logic.
One thing I want to maybe clarify is if we are in L7 and waypoint is required, no matter what, the traffic needs to go Z tunnel, waypoint, Z tunnel. In this case, that's why I made that comment about east-west gateway versus waypoint. The waypoint would be the one in the destination cluster. So if you decide that load balancing, you send if you want to send to a local in the same network, basically same cluster, then you go to a waypoint in your cluster. If you want to send to someone in a different cluster, you go to the waypoint on that cluster. And the waypoint is also acting as a east-west gateway, basically.
So that's the open question, because I think I'd been assuming that same thing, Costin, but John pointed out last week that we need to show our work there and talk through the alternatives, the trade-offs there, because there's a lot of there's actually some complexity to making that work. Before I go on, Ian, you wanted to add something? I saw you come off mute.
Oh yeah, I was just gonna agree. Like, if there's a waypoint involved, we can't skip the waypoint, whether there's a network gateway or not. Like, the decision has been made elsewhere for us. We have to use the waypoint.
I completely agree. Again, I was not saying that it's the required or the only way. I'm saying if what Lynn was saying to optimize, the most optimal path is this one. It is perfectly fine to go from local to east-west gateway and then to waypoint and then to workload. As long as
Yes.
the waypoint is co-located with the destination and it's in the path, is good. You cannot have a local waypoint applying policies locally, go to east-west gateway and then to workload.
Okay, so the waypoint will always be after the east-west gateway.
Yes, and co-located with the destination workload.
Yes, okay. That makes sense to me.
And that's also good because it has load balancing, it has information, it has more up-to-date information about security and the actual IPs. And so it's always good for the waypoint to be close to the destination.
Mm-hmm.
Keith, it might make sense to share some of the diagrams for the alternatives considered.
Yes, I was just going over there.
Because we've considered some where, you do have to go to the local waypoint, just for the sake of, considering alternatives and the benefits. There are some drawbacks to going to a remote waypoint.
Yes, there's definitely some things you have to keep in mind. There's a sidebar happening in the comments that may be useful to read, but some context before we go super far that people might not realize is that while in multi-cluster mode, Istio does read data from remote clusters, it does not, nor has it ever read Istio CRDs or policies from the remote clusters. That means that any policy enforced by proxies within a cluster needs to have that policy represented in that, but co-located with that cluster. So if you've got two clusters and an Istio in each one of them, the Istio in the first cluster does not read destination rules, virtual services, etc., from the remote cluster. It only reads services, pods, workloads, etc. And so with that in mind, we sort of break down three different options for how traffic should traverse. And big thanks to Jackie for the diagrams to help make this a bit clearer. I'll zoom in a bit here so you can see. So in this first option, we always do waypoint selection after endpoint selection. And this is a change today. In the Z-tunnel implementation today, if the Z-tunnel sees that there is a waypoint for the service that it's trying to send to, it stops everything else and just sends the waypoint with a cluster bit. Then that's the end of the Z-tunnel processing. Option 1 changes that, and we delay the waypoint traversal until after the Z-tunnel has picked an endpoint. The reason for that is twofold. For one, picking an endpoint first allows us to be able to apply capacity logic to do the weighting essentially based on how much capacity for that service is in each cluster you want to talk to. The second option is exactly what Costin was saying before. We treat, in this option at least, we treat the remote cluster as the source of truth for all policy applying to endpoints that reside in that cluster. Sort of as a security model perspective, we don't trust a local waypoint to enforce any policies on behalf of remote workloads. We go into some details here. Jackie mentioned, though, and she's correct, that there are some potential drawbacks for this model. So today, if you send to in single cluster, if you send to a waypoint, the waypoint does endpoint selection, and when the waypoint is done, it sends to a pod IP. With this model, where you can send to remote waypoints, and potentially a waypoint gets into a remote waypoint, depending on the policy being applied. There are some you can get into an infinite loop essentially. So here's a scenario that we've written out. You've got this scenario is actually not written. We're missing a sentence. It's a sentence that died. That's bad. But basically, say you've got two clusters. Well, when we get to like 4 clusters. But you see you've got a service that's deployed across multiple clusters, call it service X. Service X, we're starting with just 2 clusters right now, has endpoints X1, X2 in the local cluster, then endpoints X3, X4 in the remote cluster. The service that is in the remote cluster has HTTP route on it that sends 50% of traffic to service Y, which is a service that only lives in another remote cluster, cluster 3, and the other 50% stays with service X's endpoints. And service Y in cluster 3 has another HTTP route, but that route sends 50% of traffic to service Z that has all of its endpoints in yet another cluster, which is cluster 4. If you've got a mesh client that sends a request to service X in cluster 1, you could get this infinite loop process where the client Z tunnel picks a remote endpoint and then sends to that remote cluster's east-west gateway, and then inner traffic goes to that cluster 2's waypoint. And then after it goes to that waypoint, the remote waypoint applies its HTTP route, which sends traffic to service Z, which is another remote cluster, cluster 3. Local waypoint or that cluster 2's waypoint sends traffic to cluster 3 with hitting the east-west gateway, double H-bone decap, goes to the cluster 3's waypoint for service Y. Service Y also has the HTTP route, which sends traffic to service Z in cluster 4, and so on and so forth. You sort of infinite loop because you have to send to a remote waypoint for policy, you never end up terminating the service routing. Every successful waypoint does service load balancing. Go ahead,
That's what X-forwarded header is for. So basically, if you know that you've been forwarded to a particular path, you know the source IP is in a different network, and then you know the waypoint can send only to local and not do further distribution. And I want to make sure I'm not saying that it's I don't want to make we don't mix security with load balancing and routing. So you may if you want to do this kind of smart L7 routing, you need to do it in the local cluster, in cluster A. Policy enforcement goes to cluster B. It's the same problem we have with ingress versus egress, of consumer versus producer. Consumer is doing load balancing, producer is doing security. That's kind of the split. And for security purpose, you need to apply some waypoint policy, some L7 policies in the destination cluster. For load balancing purpose, you need to do it in the consumer cluster, just like egress in the old model with sidecar. We have the egress policies and we have the ingress. Egress is load balancing, ingress is security.
Sure. So I think that's right, and that's the idea. The problem is with waypoints, if you don't send to the waypoint in the local cluster, you can't do certain kinds of load balancing in the consumer cluster. It's just not possible.
Yeah, I agree. Then you need 2 waypoints. That's unfortunate.
But then if you have 2 waypoints, you've got the double policy question. You need to basically split and make sure that the consumer waypoint only does the client side routing, and the remote waypoint does off Z. Otherwise, you apply policy twice. If, for example, the local waypoint adds some headers and forwards to a remote waypoint, which also adds that same header, you get the double policy problem.
No, I agree. I mean, again, it's what the requirements are is the first question. I mean, if you have requirements to enforce policies in the destination cluster, you need to have a waypoint there. I mean, it's and do the load balancing. If you need load balancing on the client side, you need to do it. It's not. So the problem is we are mixing. I mean, we keep mixing the two layers, the client layer and producer layer, and try to combine them in single waypoint. Maybe the waypoint is not even in cluster A and cluster B, it's in the middle. I mean, you have some infrastructure that is providing this, which is completely outside of the cluster. And in this case, it can do both. But the user need to choose what they want. I mean, if they want security, they put a waypoint in the producer. If they want load balancing, they put a waypoint in the consumer. If they want both, they need to put both. And if they have some trusted outside of both cluster middle ground, then they can use it. But all of them are depending on their policies and requirements. We cannot pick one versus the other.
Yeah, I think another way of saying that is that there are a lot of things users might want to do, and in Istio, we try not to prevent them from accomplishing that. It just gets to be, how should you say, there are a lot of foot guns, for lack of a better term, and you need to try to make the user aware of those. The other option that we have for completeness sake is, always into the local waypoint. And the big issue here is that the local waypoint can't know about policy in the remote cluster. And John has this in the comment, but look, this is the same issue for sidecars. But the big difference with this versus sidecar, with ambient versus sidecars, is off-Z policy. If you only send to the local waypoint and don't send to the remote waypoint, there might be an authorization policy that is in the remote cluster only that the local waypoint knows nothing about, and now you've bypassed that endpoint policy. And that's frankly unacceptable. It's like it's one con here. Yeah, exactly. Sidecars have two L7s in the path, and so they can have policy enforcement at both points. But doing that with waypoint would just not be feasible because you would skip the remote waypoint. Ian, go ahead, and then Stephen.
You can, at the Z-tunnel layer, express policy about which waypoints are allowed to talk to you. So if you say waypoint in remote cluster is allowed to reach me, and then you don't put the policy that you wanted enforced there, that could be like a config error. That's not necessarily an Istio error. If you don't trust that waypoint, don't allow traffic from it to reach your workloads.
But then you don't have multi-network. It's basically you split your traffic.
Can you repeat that again, Ian? So you're saying on the servers utility side, also in the remote cluster?
You get to express policy there about who's allowed to talk to you. So you could say, oh, a bunch of workloads are allowed to talk to me. They can skip the waypoint if they figure out a way to do so. You could express that, fine. You can say, oh, these waypoints are allowed to talk to me. You can say these waypoints aren't. If you say a waypoint is allowed to talk to you, then you explicitly accept traffic from it.
I agree with you.
That's true.
Sorry.
I feel like we got in deadlock.
So what I was going to say is that that's a very interesting use case, and you're absolutely right. It's probably the most efficient way to deal with some situations where you, again, same namespace, you can give them direct path and so forth. The problem, and that's something that we don't really have a very good solution for. If you do this, there is no good way to inform the remote waypoint that it is not trusted. I mean, you can reject the traffic, of course, but the load balancer that we discussed earlier, that Kit described, where the waypoint in the client cluster was doing load balancing and doing all the other stuff, if it doesn't have a way to know that I cannot go to the pod directly, I need to go to the waypoint, but because the policy of that you described is in place, then it will get errors. That's even more complicated. I mean, it's good, but it's even more complicated than what we discussed. It's another level of complexity.
Yeah, for sure. I think, at least in my mind, there's some assumption that the service owner in cluster 1 and the service owner in cluster 2, assuming that their waypoints have identical identities, are the same actor or the same team. If you don't want to assume that, then that's when it gets really tricky. Also, Keith, to your point, I also agree. I don't think we can distinguish.
Yeah, that's a really good point. So the namespace sameness is sort of both freeing and limiting in this point, in this case, because it limits what we can do from a off-Z perspective. But it allows us to make other assumptions elsewhere in the trust system. And so for the simple cases, like if a user is doing the happy path and just replicating everything everywhere, like they probably should with namespace sameness, then there's no problem. The problem is that users don't always do that. And we find users trying to use a mesh which has the namespace sameness assumptions baked in to also get federated use cases out of it. And I think that's been the practice for a while, and we're trying to figure out how much we can make possible with this model. But that's a really good point, Ian, about that's one of the good things about the explicit allow with the waypoint, because if the user decides to make them different service accounts within the namespace and sort of divide the waypoints out per service account, then we could actually say this waypoint can't talk to my service, don't trust it, and the traffic will error. The problem is we need to, and Costin brought this up, I think, we have no way of knowing that that's not allowed. You just see elevated errors. That's interesting. Steven, I think you had a hand up.
Oh, yeah, go ahead.
Oh, sorry. Just for the people who are a little confused, mainly me. So the problem here is that if we want to enforce authorization policy, then that can't be done by the Z tunnel, and then we have to kick that off to somebody else. And then by kicking it, we get into a loop of east-west gateway waypoint, east-west gateway waypoint, east-west gateway waypoint, where it might just never terminate. So that's why we might need waypoints on either side, or to explicitly say we trust this Z tunnel, trust this waypoint, even though it might be in a remote cluster.
So the looping problem was on to the first option we send to the remote waypoint.
Mm-hmm.
Where this option 2 in the doc, is if we send the local waypoint first.
Mm-hmm, yeah.
And if we do that, then what Ian was saying is that then that puts the service owner in the remote cluster sort of in charge to explicitly deny certain, or only allow waypoints in the local cluster to talk to it. Does that help, Steven?
Can you repeat that?
Yes. So we're talking about and we're about to get to a third option, but two different options for how we send traffic to waypoints from the Z tunnel. The first option is Z tunnel will send to the co-located waypoint depending on what endpoint it selects. So we defer waypoint reversal until after endpoint selection, and then we defer until endpoint selection, and then we pick we send to the waypoint that's co-located with the endpoint that we selected. That's option 1.
So
option 2.
Okay. The waypoint is in the remote or local cluster?
Remote.
Well, or both, I would guess, depending on which endpoint selected, right? If you have local endpoints as a local waypoint.
Yeah. Okay.
Yeah. So endpoint selection gives us our distribution, right? It makes sure that we send traffic to the correct cluster with the right frequency. But that endpoint is not necessarily the final endpoint. That's just going to get us to the correct waypoint.
Mm-hmm.
That's option 1. Option 2 is we never send to the local Option 2, we never send to the remote waypoint. We only send to our local waypoint. And if this is probably the simplest pattern, and it's a pattern that works in the quote unquote happy path if the user is replicating policy everywhere throughout their clusters, because it should be equivalent. The problem is that because the east-west gateway is, because you're going to the local waypoint, in this option, the east-west gateway would not send to the remote waypoint. And if there's a policy to deploy it in the remote cluster that the local cluster doesn't know about, and it's not replicated, then you now have a hole in your system because you're not actually applying policy on that remote waypoint. It's being completely skipped. The other option would be, and we've got this down as another alternatives considered sort of thing. You could have both, send to the local and then send to the remote, but then you've got to figure out how to prevent duplicated policy, and you've got the issue, a potential looping issue like you have with option 1. To Mike's point in the chat, we can use metadata in order to not loop, like X44, could use some internal headers. We could there are things we could do in the implementation to prevent the loop from happening, and just basically have the waypoint say, okay, now we're going to pick an endpoint and no longer send to a different service, and keep all the local. That's more of our implementation detail, but I do think it's possible. You need to explore it.
Okay, that makes sense.
And for what's
One-
that's
one
kind of
more-
how like gateway API routing with like HTTP routes works. But like if in like Gamma HTTP routes, if you have a route defined for a service bar and you have a route food defined for food that redirects to bar, it'll just redirect to bar. It won't redirect to the route or bar that may resolve to BAS or something like that. It won't do like a double hop
Well,
for
a single
exactly
cluster.
for exactly this reason.
In single cluster, multi-cluster. It's
Yeah,
not
yeah,
possible.
yes. It's single cluster, and multi-cluster is undefined, and I think that basically as part of this, we should work on defining that in the upstream spec.
Two small points. One, I said, load balancing is client side and the policies is server side. Keep in mind that two load balancings happening. One is the L4 load balancing, which zTunnel is doing, which is usually adequate, good enough. And then there is L7 load balancing that Waypoint is doing, which is, again, it's maybe better because it's after routes are applied and you may have more fine-grained understanding of where you actually want to send if you want to split traffic. But in majority of cases, I mean, at least for the customers I've seen and for the people I've seen, they may have one cluster per team. So you have, finance as one cluster and they kind of keep things separated as this way. In this case, the entire application, the entire namespace, all routes and everything are in the remote cluster. So local cluster, doesn't even have the namespace, doesn't have permission to create the namespace or the service account because, again, they want to silo, to keep things separated. And in this case, I mean, the problems that we have about routing, changing the destination and then having different loads is usually not a problem because all of them are still in the same cluster and the capacity is still kind of, you have a big cluster with a small cluster. The capacity is kind of similar it's not like you have, you split traffic between service A and service B or version 1 and version 2, and they are dramatically different and you want to send them in different clusters to split traffic. I mean, some version A go to cluster B, some version A go to cluster C. Because again, it's a far more complicated problem about how locality and cluster locality matters that we need to keep into account, and it's usually not a good idea to, kind of assume that you'll have everything and have all the knowledge locally.
So if this wasn't complicated enough, we did come up with yet another option for users who want client-side policy to apply locally, but ensures that auth does not apply, or make sure auth is applied remote in the remote cluster. And that is make the client sidecar do client-side layer 7 policy. In the past, for a while, actually, in the early days of Ambient, we often talked about the idea that sidecars would be required for like client-side overrides and things like that. And in the multi-cluster case, we would sort of extend that idea. Or egress gateway, right? Something on another L7 to hop in the local cluster that is not a waypoint, doesn't portend or even try to be a waypoint, but it's just there to apply that client-side routing. And then after that client-side routing is done, by the time traffic gets to any waypoint in the remote cluster, it would know that it shouldn't apply any client-side routing again. It just is going to do endpoint selection. The diagram's a little, I didn't get a chance to update it. It's got, there wouldn't be a sidecar in the remote namespace, but just the client would have a sidecar, and it would, and the sidecar would do the routing and then pick the destination, etc. Sidecars need to be able to parse HBone. I think they already might. They need to be able to terminate HBone. And if they don't already, we would probably want that anyway for interop purposes. Users do have to apply a sidecar, but the sidecar experience has gotten a bit better over time. Native sidecars should be supported in GA and Kubernetes. And the next Kubernetes release, Istio's support, I don't see any remaining blockers for it. And depending on the customer use case, this is where I'm looking for some feedback. I don't know how common it is for customers or for users to want to be able to have both client-side policy and remote server-side like off policy. So it might be the cost might be too prohibitive if there's an army of sidecars and an ambient mesh. One quick thing before you go, Ian, I agree with you completely, Costin, that the way as I was talking to Jackie about this, what popped into my mind is that if we try to make the waypoint do this sort of client-side, server-side split, we recreated sidecars. It's just a layer 7 proxy that is doing routing and policy enforcement. And regardless, the only question is where you stick it. And so we've got options. So this option 6, it could be a client sidecar, it could be an egress gateway. It's just deploy an extra layer 7 proxy that is not a waypoint. That's basically what this option is. Ian, go ahead.
Just speaking to your point about the sidecars, I think they do speak HBone. They don't quite follow ambient semantics correctly. And in this case, they would need to speak double HBone as well, wouldn't they? Which that is a new implementation.
Yes, because they're sending to the east-west gateway, so they need to speak double HBone. In theory, it's not super onerous because sidecar HBone send is already a thing. The implementation let me back up. We would probably need, if we did anything besides option 1, we would still need HBone semantics, double HBone implementation in Envoy, which you've avoided so far. Option 1 allows us to kick the can down the road, but option 2 and option 3 and option 6, would require a double HBone implementation in Envoy, and so we would use largely the same thing, regardless. Yes, so those are just sort of the options we came up with as we were thinking through this. Again, big thanks to Jackie for the diagrams and Mike and Stephen for talking ideas back and forth. I think from my perspective, speaking alone, I am still sort of a fan of option 1. I think it gives us or at least I'm a fan of option 1 regardless. I think option 6, where we add a different client, a different layer 7 and the layer 7 proxy in the local cluster still has some value, but probably as like a beta or GA enhancement once users come with feedback. But I think option 1 gives us the better blend or the better trade-offs towards security when it comes to the producer in the remote cluster having its policy applied at its waypoint. Something that just fits very nicely to me. I do take Ian's point around being able to do some things with the service accounts and having the remote tunnel reject, but I think the UX there is going to be a bit rough. So no rush on this. I know you've got KubeCon and things coming up, but does anybody else have any initial thoughts on the options laid out here and which one they'd prefer?
I'm going to personally take some time to read through these async, but thank you so much for writing these up in detail. This helps a lot, just kind of putting the options on the table.
Absolutely.
Thank
go
you
ahead,
so
Lynn.
much. I have a quick question. Optional 1, how do you do locality load balancer?
That's a good question, and need to go back and add that consideration to the options. So in option 1, you do lose some of the ability to do like back-end locality load balancing if you don't dedicate a separate layer 7 proxy for load balancing. The reason I say back-end locality load balancing is because uTunnel can do some outlier detection and circuit breaking for the east-west gateway, because it does speak HPhone and it can read those HTTP response codes. And similarly, like if you've got locality load balancing for actually, zTunnel does have locality load balancing, so we could provide some locality information in the workload that we representing the east-west gateway that we send to zTunnel, and it could do locality load balancing. So that's a possibility. It's just not going to be the locality load balancing at the zonal level that you would get in sidecars. Of course, but good enough. Yeah, exactly, Costin.
Okay, and I assume maybe without outlier detection too. I assume zTunnel doesn't support that.
Not today. We could though, because we could from a zTunnel to east-west gateway layer in a coarse way, because if the east-west gateway we're talking to returns a 500, zTunnel does see that, because even though we don't parse user HTTP, we still use HTTP2 for the zTunnel east-west gateway for all the HPhone actually. So we can use that to inform our outlier detection.
Okay, cool. Thanks.
No problem. Jackie?
I just had a quick question. I know we're almost out of time, or we are out of time, but for option 1, I just want to confirm my understanding. Is part of the concern that both the consumer and the producer are going to be doing load balancing? So that's kind of the concern with like the infinite loop. And then I guess in option 1, the consumer is doing security. Is that kind of the model we're operating under?
Pretty much, but I think infinite loops are a kind of red herring. I mean, it's something that we need to code to make sure it's not happening, but it's very easy. I mean, it's not really
With the forwarded for header. Yeah.
or informing. I mean, if the client has a header or some parameter indicating that, hey, I'm a remote cluster, don't send remotely. Basically, send only locally.
Sure.
It's good enough, because the waypoint will never send to a different cluster.
Got it. So something to consider, but not a blocker.
Yes, but a very, very frequent use case is the one where namespaces are not replicated in all clusters. So you have one application that is deployed in one cluster, and you do not have that particular application replicated everywhere. That's where it's becoming important to do it server side.
Yep, I agree with that. For what's worth, I don't know that the consumer is doing off-C policy for security, but I may have misunderstood that. In option 2, it would be.
No.
The waypoint would be on the remote, right?
Yeah.
Yes, but that's not the consumer. The consumer is the client.
It's a bit more complicated. I mean, again, consumer, you trust basically is the consumer cluster.
Yes.
Completely. Then it's actually the consumer cluster. It's team A that it's operating the client application that is going to enforce the policy for team B that it's operating the producer namespace, because you are going to run the waypoint that is applying policy for team B in your cluster.
Yes, I think so. Okay, well, Jackie said we are out of time, but I really appreciate folks chiming in. This is really useful. Feel free to add comments to the doc, and we'll get to them as soon as we can. Thanks, folks, and enjoy TubeCon if you're going.
Yeah, see you. Bye.
Bye.
Cheers.